Hello everyone, and welcome to another video of the workshop database on Cedar. So for this video we're gonna do some experiment with Python scripts. Run a local Python program, and that Python program will be able to connect to the Cedar database, get some data and process that data. And then next up we're gonna secondly create a Python script that is submitted to Cedar as a job, and that job connects to our database and process the data. So within our Postgres folder on our project, let's take a look on our sample script. Let's do more sample pg py. Let's take a quick look on what this script is doing, right? It gets our environment variable that refers to our user and also gets our database name, and use those information in order to connect to our database. This line is what connects to our database. Important to also mention that you use the cyclepg2 library. That's the Python library used for connecting to Postgres, and then it creates a cursor, and with that cursor it can execute queries against the database. So after the query is executed, then we keep fetching the data as we still have data here. So as long as row is equal to none, that means we don't have data anymore, our query has finished. We then leave the while loop and we jump to the finally and close our connection, right? In case we have any exception through the way between this session here, our Python script is going to roll back any of the running operations, and then it's going to exit with exit number 1, which then would tell the terminal that that action has been unsuccessfully. So first of all, to run this script is important again to load our library, our Python library. Just we have to tell the LD library path where are our Python library that connects to Postgres, and we do so either by exporting this, or as we have the set run lib pg.sh script, that makes things a little bit easier. We can just source the file by doing this, and let's take a look what is within that file. This file basically is an export LD library that tells cyclepg where is the libraries responsible for connecting to Postgres. Now we have exported our Postgres library. We then have to create our virtual environment. If you are familiar with Python, a virtual environment is an area where your libraries will be saved, and this is quite handy, and the reason is that you can keep different libraries for different projects. So if you manage multiple Python projects and you have all your libraries not in a virtual environment, that becomes quite tricky to manage different versions and things like that. So it's always advised to create this virtual environment, and the way we're gonna do this is by typing virtual env, and then we give it a name. I'll give it venv, which is quite traditional name. I'll go type my virtual environment is going to be created. Okay, once it is created, so then we have to activate the environment, and the way you do source dash venv being activate, virtual environment is activated. Now we can install cyclepg, our library, on our virtual environment, and pip install cyclepg2 library should be installed. I have mistyped something here. Yep, there's an okay, just inverted the S and I space. Then we install CyclePG. Once this is installed, then we have everything we need in order to run our process. So in order to proceed with that, we do Python, and then we call our script.py, enter, and then we see our script was run. So the query our script is running, let's take a quick look on that. The query the script is running is selecting city and population from Canada City, our table, where population is larger than 100,000, and ordering by the population on descent. So meaning that the largest city will come first. As a result, let's run it one more time, see the result. So the result we see, we have first Toronto, Montreal, and the number of inhabitants of the city that comes in front of it. That's basically the result of our query and what we want to have as a result. It also filters like cities that are larger than 100,000 inhabitants. So these are all the Canadian cities that has more than 100,000 inhabitants, and this is what it shows as a result. It also tells us which user and which database name it has used and inferred from our for our environment, the environment variables we've set up previously. So this is it for our Python script. Let's move on to submitting a Python script job to Cedar. So in order to submit a Python script job to Cedar, we do use a Cedar schedule it's called Slurm. So in order to do so, first thing, it's quite important to be in a directory that is under the project environment. So it's quite important to be in a directory that is under the project tree. So in order to do so, to submit jobs to Cedar, it's only allowed if you have a project allocation under your home directory / projects, or else another option is to submit from scratch, even though keep in mind scratch is a temporary directory. So if you want to know more, I'll leave in the comments the Compute Canada page about the file system layout we have on Cedar, and then you can learn more about the differences between project, scratch, and home. But in order to submit jobs, keep in mind, have your project under the project folder or have your project under scratch. Let's now submit a job to Slurm and use this job to connect to the database and process our dataset. First, to submit this job, let's first quickly take a look on our script and see what this script is doing. So the script we gonna use is called Python sample underscore pg.sh, and quick look on this script. The first 3 lines are lines where we are giving parameters to Slurm, the Cedar schedule, and the first line tells Slurm how long would be the time slot for this script to run, which in this case is 1 minute. Second line, it gives Slurm a job name. Third line, it says output. It basically a name for our output file for the std out of this script. So whatever information goes on to the std out will be named like this. Now, this is actually, these 3 last lines are the lines where we are actually executing our software. So the first line is again we telling this environment where are the libraries for the client of Postgres. Second line, we are activating the same way we did on the last example our virtual environment in order to load the Python libraries we require to execute. And finally, we do execute our Python program exactly the way we've done before, with the only difference that now we direct the output for a file called sample underscore pg.rep, and then we should be able to see our results on this file and see what our program has done. Now, in order to submit this job to Slurm, we use the command sbatch, and then I put my script name here, Python sample underscore pg. However, in my case, because I have two different project allocation, when I submit this, I'll be given an error. In your case, I assume you only have one, so in such case you don't have to specify which one to use. But in my case, because I have two, I have to tell Slurm which one I would like to use. The way I do so is by choosing one with the parameter called account, and then I tell which allocation I like to use, which is def-a Lopez. That's the one I'm gonna choose. In your case, you definitely gonna have different names of allocation. It depends on the PI for your project. It depends on how your Compute Canada account has been created. If you have any issue on that, please send an email to support@computecanada.ca. But your allocation should appear here. You only have to choose between the ones you have available here, and you should be able to submit your job. Now, once you choose that, you submit your job, my job is submitted. I could actually check the result, whether my job is still running, by using this command SQL -- account tells me I like to see my jobs. When I type enter, because this is a quite quick job has already finished, so I'm not really able to see my job running here. But you know, if that's a very long running job, you can always keep monitoring and querying the SQL command in order to see whether your job is still running or has finished. Now, to see the results of my job, let's take a quick look to see my files here. And I do see there is a file called sample_pg.rap that has been saved on my local directory. Taking a quick look at this file should show me the results of my job submission, which, there we go, is again the cities of Canada ordered by population and filtered by 100,000 inhabitants. So that's it for this video, guys. Thank you very much for watching so far, and I see you in the next video. Bye.